As I warned you at the beginning of section 3.7, 3.8 is just a continuation. There's just a few other types of problems that we need to look at. Otherwise, the same process will be followed. In the first group of problems, 1 through 10, we need to solve the equation on the interval 0 to 2 pi. And so it's just a matter of solving as we have done in the past. Example number 1. Cosine squared of theta plus 2 cosine of theta plus 1 equals 0. Now we do have a little bit of a problem here, and something we haven't seen is the fact that we actually have a quadratic here. So just like any other quadratic, when we try to solve, we're going to try and factor. And so what we can do here is we can take the cosine of theta plus 1 times the cosine of theta plus 1. Now granted, this is the long way, but realize the same answer is going to be given whenever we set this equal to 0 or this. So this becomes the problem cosine of theta plus 1 has to equal 0. So quickly solving, cosine of theta must equal negative 1. We only have to go around once because the coefficient here is 1. And so we have to ask ourselves, where does the cosine of theta equal negative 1? And that would be at this spot right here, the negative x-axis. So all we have to do is name that angle appropriately, which is theta equals pi, and we have solved the problem. Example number 2, cosine squared of theta minus 1 equals 0. Now the intent of this problem was to factor it, but the way I look at it, we can solve by taking or using the square root method. But realize if we'd factor this, it'd be cosine of theta plus 1 times the cosine of theta minus 1 equals 0. Or using the square root method, we get cosine squared of theta equals 1. So that means taking the square root of both sides will be plus or minus the square root of 1, which is plus or minus 1. And so then all we have to do is ask, okay, where does the cosine of theta equal either a positive 1 or a negative 1? And that occurs here and here. Once again, this coefficient here is a 1, so we only have to go through one time. So this angle right here would make theta equal to pi over 2. And the other angle would go all the way around to there, and that is 3 pi over 2. And that is the answer for number 2. Example number 3. Sine squared of theta equals 5 times the cosine theta plus 1. Now here, it's almost impossible to have two different trigonometric functions, so somehow we're going to have to change one into the other. Luckily, I look at that and say, oh, sine squared of theta, I can change that into a cosine somehow, and that would be 1 minus cosine squared theta is still going to equal 5 times cosine theta plus 1. And so where I would go from here is I would distribute the 5 so we would get 5 cosine of theta plus 5, and then I'd get everything to one side so that I get a quadratic, and then I can factor and solve from there. So to make it easier, I'm going to add cosine squared and subtract 1, and so we will get cosine squared of theta plus 5 cosine of theta plus 4, all equal to 0. And so then it's just a matter of factoring this. Cosine of theta plus 4 times cosine of theta plus 1 equals 0. Then I need to set each one of those equal to 0. Cosine of theta plus 4 equals 0. Cosine of theta plus 1 equals 0. So here I say cosine of theta equals negative 4 and cosine of theta equals negative 1. Well, we ask, where is the only place that cosine of theta equals negative 4? It doesn't, because the range of cosine has to fall between -1 and +1. So that part of it, no solution to that part. However, when we look at this part, cosine of theta equals -1, where? Right there. And so appropriately naming that angle right there, we get theta equal to pi. Example number 4. Sine squared of theta minus cosine squared of theta plus cosine of theta equals 0. Now once again, I have a grouping or two different trigonometric functions here, so I'm going to have to determine which one I want, because truly I could try either way. But the thing that's going to make me want to do cosine is because I've got this lone cosine of theta here. Realize I could have changed this to sine squared. I could have changed this to cosine squared. But realizing that this is cosine, I'm going to change this to cosine squared. So this becomes 1 minus cosine squared of theta, and then all the rest is going to remain, at least for this first particular segment. Now I can combine like terms, so I get -2 cosine squared of theta plus cosine theta plus 1 equals 0. And since I don't like the negative here, I'm going to change all of the signs, or all of the signs, and get 2 cosine squared of theta minus cosine of theta minus 1 equals 0. Now continuing here, realize that I am going to have to do a factoring, and so I will get 2 cosine of theta plus 1, and then cosine of theta minus 1. And I'm going to set each one of those equal to 0 and see what comes up. 2 cosine of theta plus 1 equals 0, or cosine of theta minus 1 equals 0. Subtract 1 from both sides here, and divide by 2, I get cosine of theta equals -1/2. And when I look, that's going to occur either in quadrant 2 or 3. Reference angle where cosine is equal to 1/2 is pi over 3. So then I just need to appropriately name this angle right here. That angle would be 2 pi over 3. Or this angle right there would be the angle 4 pi over 3. So there are two possibilities, but realize we have these over here as well. So then all I have to do here is to add 1. Cosine of theta is equal to 1. And the only place that occurs where the cosine of theta equals 1 is right there. In other words, theta has to equal 0. It would also be 2 pi, but in this case 2 pi is not included in potential answers. So number 4, theta is either 0, 2 pi over 3, or 4 pi over 3. Continuing, we look at example number 5. Number 5 has the cosine of 2 theta, and hopefully that raises an eyebrow, plus 6 sine squared theta equals 2. Now, one of the things that's going to seem a little bit strange, normally we'd want to deal with, since cosine is all by itself, that we might want to deal with changing sine squared into cosine squared. But here, if we need to remember carefully, the sine or the cosine of 2 theta can easily be transformed into a an expression using only sine squared. So that will be just as easy, if not easier. In fact, this would be pretty difficult to convert into a 2 theta So what I'm going to do is I'm going to realize cosine of 2 theta is equal to 1 minus 2 sine squared of theta. And then just everything else is the same as it was, and then it becomes relatively simple from this point. Combining like terms, I get 1 plus 4 sine squared of theta equals 2. Subtract 1 from both sides. So that's 1. Divide both sides by 4. Sine squared of theta equals 1/4. Take the square root of both sides. And so the sine of theta will equal plus or minus the square root of 1/4, which is plus or minus 1/2. And so realizing that sine is both positive and negative, that means all 4 quadrants will be involved, but the reference angle will be the same once we find it. Where does the sine of theta equal 1/2? Well, that occurs at pi over 6. So the reference angles will all be the same. So then all it is a matter of finding the 4 angles. The real name of that is pi over 6. The real name of the next angle is 5 pi over 6. The third angle will be 7 pi over 6. And the fourth and final will be 11 pi over 6. And those are the 4 answers that fall between 0 and 2 pi.